All right, so let's talk about bond polarity. So we said that the electrons are shared between two atoms, but if I'm sharing it, is it in the middle or closer to one side than the other? So covalent bonding is covalent bonding is between unlike atoms. So if it is unlike, if the atoms are unlike in a covalent bond sharing, this is going to result in unequal sharing of the electrons. All right, so what that means is if I'm an atom and this is a different atom and we're sharing the electrons, if we are not the same, then that means that these electrons aren't going to be shared equally. So think about it's almost like a little tug of war. One of us is going to pull the electrons closer to the other person, and so they're still between us, we're still sharing them, but they might be a little closer to me than the other. So if we're talking about our book, maybe I can't read as well. Can't see as well, sorry. If I can't see as well, I might need the book closer to me than to the other person, but we're still sharing it, okay? So if we're not the same, exactly same, then there's going to be an unequal sharing. One atom is going to pull the electrons closer to its other side, and then one end of the bond is going to have a larger electron density. So if I pull the electrons to me, I'm going to be a little more negative than the other atom where the electrons are not as close to it. Okay? So what this is, when we're sharing it, it's still a covalent bond because we're sharing. So he's still sharing, but because it's unequal, we call this a polar covalent bond. So this is a polar covalent bond. So if I'm sharing it, whoever is pulling the electrons closer, so if I'm pulling the electrons closer, I'm going to have a little bit more negative. So I get what's called a partial negative. So this is just a delta symbol with a negative because it's a partial. I'm not pulling it so much that now I'm an anion. I just have a little bit of negativity because I'm still sharing it. And then the person, the element, the atom who doesn't have the electrons as close to it is going to have a partial positive charge right here because the electrons are further away from them. Now, this partial negative and this partial positive, this isn't just a theoretical thing. It actually is going to affect how the how the molecule behaves. So let's look at this guy. So this is HF. So we have HF here, and there's a difference in En. En stands for electronegativity. So I'm going to talk about that on the next slide, but there's got to be something that tells me, well, who's going to do the more pulling? Okay? So here, the higher the En, the more pulling. And we'll talk about what it means in a second. But all you need to know is that F is going to pull. So the F is going to pull the electrons closer. So if they're still shared, but instead of them being in the middle, they're kind of pulled closer to the fluorine. So if it pulls closer to the fluorine has a partial negative, the hydrogen has a partial positive. It actually is going to affect how this molecule behaves. So if I put this molecule as a partial positive, has a partial negative in an electric field, I turn it on, right now it's off, if I turn it on, so there's a negative and a positive side, this molecule is actually going to align so that the partial negative side is next to the positive field, and the partial positive is next to the negative field. So when we talk about this polarity in the bond, it's a real thing. It actually affects the behavior of the molecule. So it's something we need to take into consideration when we start talking about characteristics and properties. So on the next lecture, we want to talk about, well, how do I know who's going to do the pulling? I hinted at something called electronegativity. And on the next lecture, I'm going to tell you what that is exactly.